In this tutorial, I'm going to be solving two problems that it's going to be using the equations from the four simple gas laws, whether it's Boyle's law, Charles' law, Gay-Lussac's law, or the Avogadro's law. But instead of using the individual equations from those four gas laws, I'm going to be using the combined gas law equation. I'll tell you how you can retrieve the actual equation that's going to be needed to solve the problem. So let's see, this problem reads we have 22.5 liters of nitrogen gas at 748 millimeters of mercury, and it's compressed to a different pressure, which is 0.68 atmosphere. Now the question tells you it's the temperature is kept constant, all right? So that's the big hint there, and you have to figure out what the new volume going to be. Now the question doesn't really talk about the moles. Anytime if you have a question that doesn't really talk about the moles, it's safe to assume your moles are constant because all these gases are going to be studied in an enclosed container where you're not losing the gas and you're not gaining any gas material. So your amount of gas stays the same. Okay, so since I know my temperature is constant and moles are constant, let me go ahead and write down what we are given. So I have this first volume, so I'll call that V1 to be 22.5 liters. And then I'm asked to calculate the new volume. So your V2 is what we're trying to figure out. And then your P1 is going to be 748 mm of mercury, and it's your new pressure is going to be the P2, and that's going to be 0.68 atmosphere. One mistake a lot of times students make that they mix up their sets. So remember this 22.5 liters of gas corresponds to this 748 mm of mercury. So if you call this gas to be V1, this volume to be V1, this must be your first pressure. So you don't want to call that P2, otherwise your questions is going to come out to be incorrect. Okay, the other problem I see here is your pressures are given in different units, so you want to make sure you're able to convert them in the same unit. In this particular case, we're not using the R, so it doesn't matter whether you use mm of mercury or atmosphere in the calculation, as long as they are both the same. So let me just go ahead and convert this mm of mercury into the atmosphere. So remember what's the relation between the atmosphere and the mm of mercury. So I'll put mm of mercury on the denominator and the atmosphere on the top. So 1 atmosphere is 760 mm of mercury. So when I do this math, so we got 748 divided by 760, that's going to be 0.98 atmosphere. So your initial pressure is 0.98 and you have changed the pressure to 0.68, so you're decreasing the pressure. So what would happen to the volume in that case if you're keeping the temperature constant? Well, it should increase, so let's just double check that. So let me go ahead and write down my combined gas law equation, which is P1 V1 over N1 T1, and that's going to be equal to P2 V2 over N2 T2. Now remember, the temperature and the moles are constant in this particular case. So anytime you figure out what are your constant terms, you take those out. So I'll go ahead and take out this N2, N1, and I'll take out this T1, T2. So when I take those out, your leftover equation looks like this. We have P1 V1 equals to P2 V2. And I'm trying to figure out V2, so I'll go ahead and write down V2 going to be equal to P1 V1 over P2. So your P1 is given to be 0.98 atmosphere. Your V1 is 22.5 liters. Okay, and then your P2 is going to be 0.68 atmosphere. So when you set those equation or calculations right, your units will cancel out except the one you're looking for. So in this case, the atmosphere cancels out, and then your answer is going to be left only in liters, and that's the unit we really want. So let's do these calculations. We got 0.98 times 22.5, okay, and divide that by 0.68, and it comes out to be 32.4 liters. Okay, so what we have said earlier, if your pressure drops down, your volume should go up. So your V2 has gone up to 32.4 from 22.5 liters. So that's how you're going to be using the combined gas law equation to retrieve an actual equation you're going to be needing to solve the problem. Okay, let's try another question here. And now, to solve this problem, you may want to kind of pause the session here and solve it on your own and see if it matches with my answers. So it says I have 400 milliliters of gas contained at 300 mm of mercury at 0 degrees Celsius. Okay, and then it's asking what's the new volume in milliliters, okay, if the pressure, so this at 56 kilopascal is going to be your new pressure, and 10.0 degrees Celsius is your new temperature. So remember, this is going to be your first set of information, and this right there is your second set of information, so make sure you don't mix those up. So I have V1 to be 400 milliliters, and then I got P1 to be 300 mm of mercury, and then I have the temperature T1 to be 0 degrees Celsius. And remember, I can't really have 0 degrees Celsius. Your temperature must be in a Kelvin scale, so I'll just go ahead and change that right away. So all I really got to do is add 273 to it, so 273.15 rather. So your temperature in Kelvin is going to be 273.15 Kelvin. Okay, so then this is your first set. Now your second set will look like this. I have V2 is what we're trying to figure out. Your P2 is actually 56 kilopascals. And if it's a kilo, what does that mean? It's 56 times 1,000, so it's going to be 56,000 pascals, because kilo is a prefix that means it's 1,000. And you have the temperature, which is going to be 10 degrees Celsius. So make sure you change that to Kelvin by adding 273. So 10 degrees Celsius plus 273.15, and that's going to be 283.15 Kelvin. So that's how you change the temperature. That's going to be T2 rather. Okay, so then it doesn't really talk about the moles. So since this gas is contained in some sort of container, you're not losing the gas and you're not gaining the gas. So that means your mole's going to be the constant here. Okay, so that's the main thing. You want to make sure you have that down. And then let's look at the units, make sure all the units are the same. The volumes are fine. Your pressure is actually a little bit different. You got 300 mm of mercury in one case. So let me change that real quick here. And your P2 is actually in pascal. So maybe you want to change either both, either mm of mercury to pascal, or change the pascals to the mm mercury. And you don't have to worry about using the atmosphere in this particular case, because we're not going to be using the R. And if any time you're doubt whether you need to use atmosphere or not, you can just always convert the units into atmosphere and just be on the safe side. So if I want to go ahead and convert this pascals into mm of mercury, so remember the conversion factor is going to be 760 mm of mercury is going to be 101325 pascals. So that's the conversion factor you want to make sure you must know. So when I do this math, I have 56,000 times 760 divide that by 101325, so it comes out to be 420 mm of mercury. Okay, so now I know everything here, so let me just go and write down my combined gas law equation, which is P1V1 over N1T1 is going to be equal to P2V2 over N2T2. Okay, so your N is constant, so I'll get rid of that. So that leaves you with P1 V1 over T1 equals to P2 V2 over T2. Okay, I'm trying to figure out V2 here, so I'll probably leave that on one side and take everything else on the other side. So P1 V1 over T1 times T2 over P2. If you have a hard time rearranging those, you can just go and plug in the values of everything and solve the V2 that way. It doesn't matter how you do the math as long as you do it right. So your V2 here, your P1, let's go back and check what the P1 was, is 300. So I write down 300 mm of mercury times your V1 is 400 milliliters, and your T2 is 283.15 Kelvin, and that's going to be divided by your T1 and P2. So your T1 is actually 273.15 Kelvin, and your P2 is going to be 420 mm of mercury. Okay, so when you solve this, let's see whatever that comes out to be. All right, so after doing this math, I get my new volume to be 296 milliliters. Okay, so that's going to be the final volume in this particular case. Hopefully this video was helpful. If you have any questions, feel free to leave the comments